Good morning everyone. My name is Aayushi and my USN is 009, and today I am explaining Verilog program for the multiplexer. So first we will understand what is multiplexer. So multiplexer means many to one. So it is a type of combinational circuits in which we give many inputs and we get one output. And it contains a control signal as well on which the output is based. So on the basis of selection lines, first we will see the circuit diagram. So if there are n selection lines, there are 2 to the power n input lines and we get one output as we can see. So on the basis of the selection lines, number of selection lines, there are various types of multiplexers. So we are discussing three types of multiplexers here. 2 is to 1 multiplexer, 4 is to 1 multiplexer and 8 is to 1 multiplexers. So first we will see the 2 is to 1 multiplexer. As we can see in the block diagram, there is one selection line. So 2 to the power 1, which is 2. So there are two inputs I0 and I1 and we are getting one output. So in the truth table, as the value of S0 can be 0, can be either 0 or 1. So whenever the value of 0, the I0 input will be selected as output. So in the case of 0, I0 is selected. So whatever the value of I0, it will be taken as the output. So here I0 value is 0, so the output is 0, and I0 value is 1, so output is taken as 1. So when the S0 value is 1, whatever I1 is selected as the output. So whatever the value of I1, irrespective of the value of I0, it will be taken as the output. So here I1 value is 0, so the output is 0, and when I1 value is 1, the output is 1. So we will discuss the code for 2 is to 1 multiplexer. So for 2 to 1 multiplexer, we gave the module and we named it as mux_2_1, in which there are 4 ports: S, A, B, and mux out. Here, this is S, which determines input will be passed to the output. S determines the input will be passed to the output, and A and B are the data inputs and mux out is the output. Mux out is considered as register because its value will be assigned in always block. Okay, so for the always block, here always is used whenever any inputs change. That's why we gave value SAB, because these are the values which get triggered. So begin indicates the starting of the always block. In always block, there are two cases in which the values of S can be changed. So whenever the value 1-D0 defines the value of S. So whenever the value of S is 0, the whenever the value of S is 0, the output is set to A, and whenever the value of S is set to 1, the output is set to B. And so these are the two cases, but there is one other case can be happen, which is like when we give some unexpected value for S. So in that case it does nothing. End case is used for uh, uh, it indicates the ending of the cases, and end defines the ending of the always block, and end module defines the ending of the module. So we can define it with test benches as well, which we'll discuss. So for okay, so for 2:1 multiplexer, this is used for the testing of the functionality of the 2:1 multiplexer, in which we have defined S, A, and B as registers because they will be driven with the values of the test bench, and mux out as wire because it will be driven with the multiplexer module. So the mux underscore 2 underscore 1 unit under test, it connects the input and outputs of the module of the signal declared in the test bench. So it connects S connect to the register in the test bench S, and similarly A and B are connected to the register A and B in the test bench. Similarly mux out. So here are the cases which can happen. So there are total 8 cases which can be happen in um, 2:1 multiplexers. So here display is used for displaying the values, and monitor will monitor and print the values of A, B and output. So the S value can be 0 in 4 cases, and 0, 1, 0, 0 and 4 times, and S value can be 1 4 times for the 4 cases. These are the total 8 cases in which A value is 0 0, A value is 0 0, 1 0, 0 1 and 1 1. Similarly for S is equal to 1, A is equal to 0 0, A is equal to 1 0, A and B 0 1, and A and B is 1 1. So these are the total 8 cases. Whenever the value of S is 0, A is taken as A is set to the output, and whenever S value is 1, B is set to the output. And hashtag 10 defines wait for 10 time units before moving to the next set of values. So it indicates the finished and end module. So this is the circuit diagram. Here we can see that whenever the value of um, S is 0, it indicates I naught, and whenever the value of S naught is 1, it indicates the value of 1, I1. So in the software, it shows output like whenever here are S, A and B are inputs and mux out as the output. So here as we can see, S value is 0 here and 1 here. So whenever the value of S is 0, it will take whatever the value of A is. So here A is, we can see here S is 0 and A is 1. So the mux out value is also 1. And when here here A value is 0, so mux out value is also 0. But here S value is 1. So whatever the value of B, it will be taken as the output. So B value is 1 here. So the output is also 1. So this is the explanation of 2:1 multiplexer. Now we will continue with 4:1 multiplexer. So in 4:1 multiplexer, there is a 2-bit selection input lines. So if there are 2 selection input lines, 2 to the power n, which means 2 to the power 2, then there are 4 inputs and we get 1 output. So on the basis of that, this is the truth table. This is the truth table. As we can see, whenever the S value is S0 and S1 value is set to 0 0, the selection in the output is selected as I0, and when the selection line is 0 1, it is I1, for 1 0 it's I2, and for 1 1 it is I3. So we'll discuss a 4:1 multiplexer Verilog code first. So module name is mux underscore 4 underscore 1, where A, B, C, D are 1-bit inputs and S is 2-bit selection input, and mux out is declared as output. It is declared as register because it will be executed under always block. All the variables, whenever the variables get triggered, always block will start executing the cases. So now there are 4 cases. So 2-D0, it defines like whenever the S is 2-D0, which means the S0 and S1 values are 0 0 and 0, the output mux out will be assigned the output the value of input A. The output mux out will be assigned the value of input A, and whenever the value is 1, which means 0 1, the output is assigned to input B, which is I1. Similarly for 2, which is 1 0 case, the output is assigned with the value of input I2, and similarly for third case, the S0 value is 1 and 1, the output is assigned with the value of D, which is I3. And default, if any unexpected value we got, and this is for ending of the case block, and this is for the ending of always block, and this is for the ending of the module block. So now we will see the test benches. Here, as we can see in the diagram, for I0 value, the S0 inputs are S0 and S1 inputs are 0 and 0. For I1 it is 0 and 1. Then for I2 it is 1 and 0, and for I3 it is 1 and 1. Now for the test benches, we can see module name is mux_4_1 test benches tb. Then this is a 2-bit register for the selection line S0 and S1. Then A, B, C, D are the inputs, and wire mux out is the output line, which will be connected to the module 4:1 multiplexer. Then so there are 4 cases. So whenever the value of S0 and S1 is set to 0 0, A is set to 1 and all other inputs are set to 0, because I0 will be taken as the output. For the case S0 value 0 and S1 value 1, B is set to 1 and all other values are set to 0, because I1 will be taken as the output. For S0 value 1 and S1 value 0, C is set to 1 and I2 will be taken as the output. And for S0 value 1 and S1 value 1, D is set to 1 because I3 will be taken as the output. So these are the 4 cases which we have taken in test benches. Now we'll see the graph. So as we can see, for the 0 0, it will take whatever the value of A is. So A value is 0 here, so the output is also 0 here. For 0 1, whatever the value of B is, it will be taken as the output. So B value is 1 here, so the output is taken as 1 here. For 1 0 case, whatever the value of C, it will be taken as the output. So C value is also 1, so the output is also 1. So, and for 1 1, whatever the value of D is, it will be taken as the output. So D value is 0 here, so the output is 0 here. This is for 4:1. Now for 8:1, 8:1 multiplexer, it has 3-bit input selection line as a selector to choose which one of the 8 input is passed to the output mux out. So there are 8 inputs and 1 output, and there are 3 selection lines, which means 2 to the power 3, which is 8. There are 8 inputs. So on that basis, S0 values are shown here. So these are the cases. For 0 0 0, it will take D0 value, 0 0 1 D1, 0 1 0 D2, 0 1 1 D3, 1 0 0 D4, 1 0 1 D5, 1 1 0 D6 and 1 1 1 D7. So we will see the code for 8:1 multiplexer. So module name is mux_8_1, in which we have taken S as the 3-bit binary selection line, and these are the inputs, and mux out is the output. It is set to register because it will be executed under the always block. Always block gets triggered whenever the inputs get changed. So there are 8 cases for 8:1 multiplexer. So whenever the value of 0 defines as 0 0 0, which is the first case. So whenever the value is 0, output is set to A, which is D0, and similarly whenever the value of S0 is S0, S1, S2 as 0 0 1, it is the first. This is like, should I write? Whenever the value is 2, it is set to D2, which is C. Similarly for 3, which is 0 1 2 3 0 1 1, it is set to D3. For fourth case, it is set to 1 0 0. For fifth case, it is set to fourth. So for the case of sixth one, 1 1 0, it is take value D6, and then for 1 1 1, it will take the value as D7 input D7. So this is the ending of the case, and this indicates the end of the always block, and this indicates the end of the module. Now we'll see the test benches. So here we have 3-bit input selection line, and A B C D E F G H as inputs, and mux out is the output. Now this instantiate the module mux_8_1 in the test bench, in which it connects. S is connected to the S register in test bench. Similarly, all the inputs are connected to the respective register in the test bench, and similarly for the output, it is connected to its wire register in the test bench. So display function is used for display, and monitor function monitors and prints the value of all the values given. So there are total 8 cases are there, in which whenever the value is 0 0 0. So whenever the value is 0 0 0, A is set to 1 and all other inputs are set to 0, because it will be taken as the output. Similarly for the case 0 0 1, B is set to 1 and all other inputs are set to 0. For the case 0 1 0, C is set to 1 and all other inputs are set as 0. For the case 0 1 1, D is set to 1 and all other inputs are set to 0. For 1 0 0, E is set to 1. For 1 0 1, F is set to 1. For 1 1 0, G is set to 1. For 1 1 1, H is set to 1. And these are all the test benches, and this indicates the finish, and end is the ending of the initial begin block, and end is the end module. Okay. So here this is the selection line. For 0 0 0, whatever the value of A, it will be taken as the output. So its value is 1, so the output is 1. For 0 0 1, whatever the value of B, it will be taken. So here it is 0, so the output is 0. For 0 1 0, C value is 0. C value is 0. So C value is 1. So the output is taken as 1. For 0 1 1, D value, which is all 1, so it is taken as the 1. Then for 1 0 0, whatever the value of E value is 0, so the output is taken as 0. For 1 0, for 110, G value will be taken. G value is 1, so it will be taken as 1 output, and for 111, H value will be taken, so it is 0, so it is also showing 0 here. Thank you.